All right, in the past, you should have learned about factoring quadratics because this is a big idea. So this isn't something that you can say, oh, that was difficult, I'm glad the unit has finished and we've moved on. This is something where once you learned it, you're going to do it for math class for the rest of all time. This is something that shows up all the time. It's supposed to be as basic as adding and subtracting. So we need to get really, really good at it. So these notes are going to be our factoring notes. You are going to want to put these in a place where you can refer to them often because you need to come back and be familiar with these and be really good at them. So we have a few different methods. We have the greatest common factor. And this is like the most basic type of factoring. This is the type of factoring we're going to look for in every single problem. It doesn't matter if it has 2 terms or 3 terms or 4 terms or 5 terms. We are always going to look for this. So I'm going to show you the greatest common factor in a very simple case, like x squared plus 5x. This is called a binomial because it has 2 terms, binomial. And if you look at this, the greatest common factor between these 2 pieces right here is an x, because I can see that both of them have an x involved. So it's a common factor. It's something that you could take out of both of those terms. So I'm going to take that common factor out, that x, and then I write parentheses. And in my parentheses, I write my leftovers that I get when I divide x out of each term. So x squared divided by x leaves us with just an x. 5x divided by x leaves us with just a 5. So we would say that the factored form of this, by taking out the greatest common factor, is x times x plus 5. The next type of factoring we look at is for factoring trinomials, where a equals 1. And trinomials are always in the form ax squared plus bx plus c. So this first set that we're going to look at factoring are going to be ones where the x squared is all by itself. You have a 1 for a, which means that people typically don't write it. So we're going to leave it like that. So to start with, I'm going to give you a problem where a is not 1 so you guys can see where the greatest common factor comes in. So if I have 3x squared plus 27x plus 60, this is a trinomial, I can see because it has 3 terms. Right now my a value is 3. However, if you look at this problem, you can see that 3 is divisible by 3, 27 is divisible by 3, and 60 is divisible by 3. So that means that this trinomial actually has a greatest common factor within the problem. So I'm going to write my greatest common factor is 3. I'm going to put that out front. And then I'm going to write down what all my leftovers are after I divide that 3 out. So 3x squared divided by 3 is just x squared. 27x divided by 3 is 9x. And 60 divided by 3 is 20. So that means even though I started with the 3 in the front, this is still a problem where the a value is 1, because once I take out that GCF, I have this really simple trinomial here. All right. So we have 2 different ways of doing this problem that I'm pretty familiar with. Your other teachers might have had other ways, but typically we look for something that multiplies to be 20 and adds to be 9. And they often write that information in a little x like this. So we're going to say it multiplies to be 20, and it adds to be 9. So that would leave you thinking of the 2 numbers that would do that. And the 2 numbers that multiply to be 20, that add to be 9, would be 4 and 5. So when I finish this problem, I'm just going to say, all right, I had that GCF of 3. I had a factor of x plus 4, there's a plus, x plus 4, and x plus 5. It's a really common way of doing that problem. You might also see teachers that do what they call the box method. So once you know the numbers that do this, you might say, all right, I put the x squared here and I put the 20 down here. and then the two numbers that multiply to be 20 but would add to be 9 would go in these two boxes. So we'd have 4x and 5x. And then outside of those boxes, that's where we can put our factors. So I would say between these two boxes, the thing that's in common is an x. Between these two boxes, the thing that's in common is a 5. Between these two boxes, the thing that's in common is an x. And between these two boxes, the thing that's in common is a 4. And so again, if I look on the outside, I can see x plus 5 is one factor, x plus 4 is the other factor. We always have to make sure that whatever that GCF was that I took out in the beginning of the problem ends up in the final answer. So that's your factored form. We also have trinomials where a does not equal 1. So it's in the form ax squared plus bx plus c, but we actually have a number here, and it's not a number that could be taken out with the GCF. It's a number that even if you took out the GCF, there would still be something there. So my example for this one is going to be 6x squared minus x minus 2. And as you can see, I've got a number in the front, I've got that 6 in the front, but it is not a GCF. I don't see other numbers that are divisible by 6. And so that means that that 6 has to stay in the problem. So we have a couple different methods for doing this one as well. Since we just did the box over here, I'm going to go ahead and show you the box. So we're going to say, yeah, we can do the box first. So we're going to say first, to do the box method, that we have to take the 6, and we have to take the -2, and we have to multiply those together. So 6 times -2, I'm looking for two numbers that multiply to -12, but add to this number here. And since it just says negative, if there was a number there, it would have been a 1. So we're looking for numbers that multiply to -12 and add to -1. And the two numbers that would do that would be -4 and 3. -4 and 3. So if I draw my box, then I'm going to put a 6x squared up here, and I'm going to put a -2 down here, and the two numbers here and here should add up to -1. So those are these two numbers here, the -4x and the +3x. And when you do this type of problem, you're going to get these two numbers. It doesn't matter which box you put them in. You could switch them and you'd end up getting the same answer. So when I look now, I'm going to say between these two boxes, what I can see in common is that both of those numbers are divisible by 3. And I can see that both of those have an x in it. So I'll take the x and put it there. Between these two boxes, I can see that both of those have even numbers. They're both divisible by 2, and they also both have negatives. So then I've got a -2 right there. Between these two boxes, I can see that they're both divisible by 2, and they both have an x in there. So I'll go ahead and take out that 2x. And then these boxes do not appear to have anything in common at all, so I'm just going to put a 1 there, because there always has to be something. So if there's nothing that I can see, then I'm just going to put a 1. And you can always double check your work just to make sure that if you multiply these back out, they really would equal what you want them to. So 2x times 3x is 6x squared. 3x times 1 is 3x. 2x times -2 is -4x. And 1 times -2 is -2. So these parts on the outside are what my factors are. So my factors would be 3x minus 2 and 2x plus 1. There's my factors. All right, now there's another way you can do the same problem that is called slide, divide, bottoms up. You'll find some math teachers really like this and some math teachers hate this. So I'm going to go ahead and teach it to you, and if you don't like it, you don't have to use it. So with slide, divide, bottoms up, the first part is the slide, and that's what we did when we did 6 times -2. So I'm going to go ahead and just show my work here again. So here they might write their work like that. So they're saying they slid the 6 over to the -2, and that's how they got -12. And then again, we're going to say numbers that multiply to -12 but add to -1, and that would be -4 and 3. So again, the same numbers. Now here, we kind of do the problem like we did up here, where we said, all right, my two numbers were 4 and 5, so I write them in parentheses, 4 and 5. But up here, we're done. Down here, I go ahead and I put those in my parentheses. I say x minus 4, x plus 3. But I've only done the first step. I've only done the slide. The next step is to divide. So whatever number you slid is the number you divide by. So 6 is the number I slid. I'm going to go ahead and write divide by 6 right here and divide by 6 right there. Once you have done slide divide, you're left with two fractions. And any time we work with fractions, we always want to simplify them. So 4 over 6 simplifies to 2 over 3. 3 over 6 simplifies to 1/2. Sometimes when you simplify these, they'll divide evenly. So you might have had 6 divided by 3 equals 2 or something. So sometimes they'll divide evenly and you'll get a whole number, sometimes not. And then what you do from there is you do bottoms up. So this bottom moves up to the front, this bottom moves up to the front. And you get 3x minus 2, and you get 2x plus 1. Two completely valid ways of doing the same problem. So what I would say is don't go back and forth between the two. Pick one and commit to it and use that every time so that you can memorize the process and get really good at them. Okay? All right, another type of problem is called difference of squares. And this is a problem like if we had 5x squared minus 80, and you wouldn't be able to see it right now. Squares are things like x squared or y squared, or it could be a number like 4, 9, 16, 25, 36, 49. So squares are something that have been squared. This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. So that's what squares are. Now here, I can't see these square numbers because there's a GCF in the problem. So before I do this, I have to say, okay, I've got a GCF of 5 that I need to take out. And when I take 5x squared and divide it by 5, that leaves me with x squared. When I take 80 and divide it by 5, that leaves me with 16. So this is minus 16. Now I have a square here. So when you do difference of squares, you're looking for perfect squares. You will often see that these are binomials, so there's two pieces, and it says difference of squares, not sum. It says difference because this is a minus problem. All right, so when you do difference of squares, you get two sets of parentheses, one with a plus, one with a minus, and then you just take the square root of each term. So the square root of x squared means that I just have x times x. The square root of 16 means I've got 4 times 4. So there's how we factor difference of squares. All right, so one important thing to remember is always check for a GCF first. Always check for a GCF first. Highlight it, underline it, star it, whatever you need to do. That is something we have to make sure we check on every single problem. All right? So if we look back at these different methods we used, our little shortcut of saying what multiplies to 20 and adds to 9 and just put those numbers here, that only works if you've taken the GCF out first. This method right here, the box method, only works if you've taken out the GCF first. This method here, slide divide, bottoms up, it only works if you've taken out the GCF first. Correctly factoring difference of squares only works if you've taken out the GCF first. So that's something that we always have to check, is we want to see if there's a number in common that we should take out, or if there's a variable that shows up in every single term that we should take out. We always